Alright, so number 8. A 8.5 gram bullet. Ooh, right away I start thinking, ooh, I gotta work in kilograms, not grams. Has a speed of 1.50 kilometers per second. And I think, oh, wait a minute, maybe I need to work in meters per second. What is the kinetic energy of the bullet? So I'm going here, and this is number 8. Anybody have a favorite color of text?
Blue.
Blue, I heard first.
White.
Why isn't this whole 18? Blue. Alright. So, let's see. I need to show that I understand kinetic energy. Kinetic energy is due to an object's inertia and speed. The faster it moves, the more KE it has. The more inertia it has, the more KE. I don't think it's anything else. That's about it for this one, because I mean it's a very kind of straightforward lie. We're just using the definition of kinetic energy here. Any questions on the lie rate? So let's move on to the how. Remember, this is my rubric here for the how. So I need an equation. And since this is about kinetic energy, I'm going to guess that I'm going to start with our base kinetic energy equation. And we'll paste that in. Right, and then I need to be careful of my units. What I like to do with units is right away work in my base units rather than in my my other ones, my whatever they give it to me in. All right, so this one gives me my values in not my base units. At 8.5 grams, I should use kilograms rather than grams, right? So if we go into here and 10, go red. So 8.50 grams is equal. I'm going to run into stuff. That's going to be 8.50 times 10 to the minus third kilograms, right? Because there's 1,000 grams in a kilogram. And then I look at my speed, and that's in kilometers per second. What is that, 1.5? Yeah. So 1.50, oops, not times 10. Kilometers per second. That's going to equal 1.50 times 10 to the third meters per second. Because I know that there's 1,000 kilometers in a meter. So we're going the opposite way. Right? Now if I use kilograms and meters per second in my equation, I'm going to end up with the base unit of energy, which is joules. So now it's really just substituting in. So I'm just looking back at kinetic energy. 1/2. Oops. I'm getting used to this new board. And 10 to the minus third kilograms times 1.50 times 10 to the third meters squared. And that's going to give me whatever it comes out to be in joules. Now, did the problem ask for me to give the answer in joules? What do you think? No, it says kilojoules. Watch this little trick. Click in there and do backspace. Oh, now it's in joules. Yay! Or I could convert from joules to kilojoules, because we know that there's 1,000 joules in a kilojoule. So, but I just changed it to joules.
Yeah, I know.
All right, so number 10. Dog is running with the speed of this, has the momentum of this. What is the mass of the dog? All right, so. I don't know why this one's cold as I. Oh, what was the second favorite color?
Yellow. White.
Sure, I'll do it in white. So, I wish I could do a background color. I like purple. We'll do purple. How about that? The momentum of the dog is due to it having inertia and it being in motion. The mass of the dog is used to measure the inertia. The velocity of the dog is used to describe its motion. I mean, this one is kind of like Ethan. It's fairly straightforward. So your Y really doesn't have a lot of kind of meat to it, but all right. So that's kind of what you would have. Any questions on the Y? All right. Go down here to our how. And this is about momentum, right? I didn't mess that up. Okay. So I need an equation that relates inert speed, which is just, in this case, we can name it as velocity without the direction, the momentum, and to the mass, the inertia. So, I have a momentum equation. Yay! And now, let's see. let's look at our units here. Let's see if they're nice to us unit-wise. Meters per second, so that's our base unit of speed or velocity. And kilogram meters per second, that's our base unit of momentum. So what they've told me here is that the velocity is, of course I forgot the number, 1.9. 1.9 meters per second. And that the momentum is 16 kilogram meters per second. Right? I've dropped my vector symbols because they didn't tell me the direction. But I know that whatever direction my velocity is in, my momentum's in that same direction. Because that's how it works. So I'm not going to worry about direction. So now I can just substitute in, right? 16 kilometers, kilogram meters per second equals whatever the mass is times, oops, I didn't put down enough, there you go, 1.9, solve for m, and it will be in kilograms. So I have kilogram meters per second here, meters per second there. That means, yay! And there was much rejoicing.